Good morning, everybody. My name is John Greenfield. I'm the Director of Business Development and Partnerships at Everactive, where we are generating self-powered insights for the physical world. I'm joined here today by our co-founder and co-CTO, Dave Wenzloff. He'll be on the panel later on today. And our MIT connection here is that he did his PhD with Professor Chandrakasan, along with our other co-founder, Ben Calhoun. Their focus was ultra-low power circuit design, which we'll talk about in just a moment. So at Everactive, we believe that the industrial IoT specifically, but the IoT generally, and specifically the IoT of our that we've been promised by Gartner, IDC, and many other analysts, is currently being held hostage by batteries. In particular, we are focusing on taking the research that Ben and Dave have done for the better part of 2 decades in order to build completely self-powered sensors. That means that they're entirely maintenance-free, can go where other people can't. Sometimes that means they're in difficult to reach places or they're in dangerous places. Sometimes it just means that they're able to be in volumes that you can't think about or think about deploying today because you're held back by batteries. We use those sensors and do the hard work of integrating them with harvesters, radios, and other equipment, basically all the components that you need to build an end-to-end system, connect those systems to the cloud, and do all of that work for our customers so that we can provide them an end-to-end solution which they can install on devices in about 5 minutes or so. And finally, building on what David was talking about earlier this morning, we bring it to market as a service. So what that means for our customers is that there's absolutely zero upfront capital cost, so no hardware cost associated with starting with us, and our customers receive automated notifications. So think emails, text messages that tell them what's going on with their machine rather than providing them with a stream of data that they don't have enough time to analyze today. Our first product was released in Q1 of this year. It's very specific, focused on a valve and steam systems called a steam trap monitor. If you know it, you know it. If you don't, you don't. That's fine. But what we're doing here and what's important to note is 2 things. So we are collecting temperature data on either side of that valve continuously, so about once every minute today, so thousands of data points per day. And we're powering the device from a small difference in temperature, so thermoelectric generator if you're familiar with energy harvesters. That's helping our customers today reduce downtime, reduce energy loss, and importantly, it helps on both the economic side and on the environmental side, so both a compelling economic and environmental return. You can think about, so we talked about cloud connected. Once our customers have gateways in their environment, it's very simple to add another monitor, another asset. And our second product, which will be released in Q1 of next year, is focused on machine health, so particularly vibrating and rotating equipment. Similar idea, monitor without batteries, monitor the balance of plant assets in order to know exactly what's going on with them. So where can you guys come in? We believe that we've taken this very specific approach of building a full system, and that's meant that we've needed to start narrow with specific assets. There's many, many more opportunities to work on other assets. A couple of the ones that we've thought about and done research on are included here to the right. We see a great opportunity for partnering on new product development with industrial OEMs. In addition, industrial is just a start. So we're very focused in industrial today, but where can you apply a batteryless maintenance-free system to sense the physical world? Almost anywhere. So if there are places that you're interested in doing that, we'd love to talk to you as well. Thanks very much, and we'll talk to you this afternoon.
Hi, good morning, everyone. I am Ashish Yadav. I am the Director of Software at Precision Devices. We are an MIT startup, and we are building a next-generation design automation platform for Internet of Things. So IoT is rapidly expanding in many industries, and based on our previous venture, where we supported hundreds of customers and deployed thousands of devices, many of our customers requested for an internal design automation platform. And we also felt that there's a need for such a platform where customers' internal IT teams can use to evolve their IoT needs and their IoT solutions. But because the IoT technology stack is very complex. It requires domain experience, IoT expertise, and it has a distributed topology and fragmented applications. These challenges make it really difficult for any organization's internal IT team to evolve their IoT solutions and their IoT needs. And we believe that now we have a solution for this. So our solution is Prescient Designer. It's a design automation platform that enables customers to design, manage, and visualize their entire IoT system at scale. Our design automation platform, it leverages on an open source flow programming editor that enables managing and automating distributed devices and fragmented applications inside the same designer. So using our design software, companies can manage and evolve and visualize their entire IoT system and update and scale it according to their needs. An example use case is smart manufacturing, where each manufacturing plant can have hundreds and thousands of distributed and fragmented devices. We enable the organization's internal IT team to scale those solutions as per the need. And we also help them in IoT systems and hardware, and we can also help customers build full solutions from ground up. So to summarize, if you need to design, manage, and evolve your IoT solution, IoT needs, and we believe that most organizations will face this challenge very soon, then we have a solution for you. Right now, we are targeting industrial and manufacturing sectors, but our platform is robust enough to support any distributed and fragmented IoT system. So please let me know if there's any interest. Thank you.
Thanks. All right, thanks. Let's see here. Maybe? Uh-oh. Of course. Green button not working, even though there's a big piece of tape that says click green arrow. Okay. All right. Good morning, everyone. We're super excited to be here with you this morning. My name is Cody Falcon. I am the Global Vice President of Product Development at Arundo Analytics. We are a software company that is focused on transforming heavy industry by helping our customers move from data-driven insight to business value. We are a proud STEX 25 alum, and we maintain our deep MIT connections to this day. So today's talk, I'm on the clock here. I've got just a few minutes. I'm really going to focus on the edge. So our first product went to market in 2017, and since 2017, we have spent every single day of the week in the field directly with our customers in what we describe as the industrial internet. So today our customer base includes some of the largest oil and gas companies in the world, some of the largest shipping companies in the world, all the way down to local regional utilities. So the hard lessons learned for Arundo as a startup in the last 2 years, the number one pain point is data stuck on legacy assets. 75% of our use cases and our applications running in production environments today start on the edge. Why that is? There's three main problems, right? When you start on the edge, most of these control systems and this equipment did not start with or was not implemented with the industrial internet connectivity or analytics in mind. So fragmented non-standard instrumentation, so you can have the same piece of equipment in the same environment, in the same process, with anywhere from 1 to 200 sensors that have been retrofitted, all of different makes and models. So connecting into that is a challenge. Number two, closed loop and proprietary control systems. So I don't know any DCS SCADA guys or gals in the room. These things, similar to the equipment, were not built with the industrial internet and connectivity in mind. So our team today spends a lot of time building out these integrations, and today we have a pretty broad portfolio to click into these existing control systems. And the third point, which is the most painful for us in our environments, is poor, non-existent, or non-reliable internet connectivity. So earlier I mentioned oil and gas companies and maritime. Imagine a ship out at sea. You have to bring the analytics to the vessel, right? Not the data to the cloud. We work in some of the harshest operating environments down in South Texas or in the Dakotas where internet connectivity is a 5-minute satellite shot once an hour. So again, moving the analytics to the edge. How we do that and how we solve that problem, of course, we have a pretty wide product portfolio. This one specifically is our Edge Agent, and it does a handful of things. One, we built it to connect natively directly at the protocol level to the field telemetry devices and the equipment. So this is kind of as plug and play as you can get. You drop the piece of software in on the asset in the field, it auto-discovers the sensors and the tags and configure those to stream. The second point, the ability to deploy machine learning models and the applications all the way down to the edge, as you can see here. So the ask, with 10 seconds left, we would love to work or talk with anyone in the room inside this industrial space and share our broad portfolio of out-of-the-box applications, existing enabling technology, and share some of the hard lessons learned anywhere along that stack. And we, again, work across the spectrum, and we really focus on meeting our partners and our customers where they're at on the digital journey. That's it.
Good morning. Excuse the graphics, but my name is Ryan Davis. I am a co-founder of Secure AI Labs. We are helping secure data and code across your IoT networks. We're a company out of the CSAIL and Media Lab departments, and as part of my co-founder's graduate research, she helped develop this technology with Sandy Penton at the Media Lab. Now, for many of you here, you might be wondering why we're talking about security in an IoT conference. Well, security is actually the biggest barrier to the Internet of Things. And unfortunately, security also has a waterfall effect in that if you can't secure your data and your analytics, you can't get into the hands of the experts that need to integrate and solve interoperability for your companies and ultimately get the return on investment for your companies. Now, what we've built, apologies again for the graphics, is a cryptographic environment known as confidential computing. This is invented at MIT and allows you to encrypt data during use. Not just during transit, not just during storage, but actually during use. And this is a big boon for the industry because it makes it safe to utilize this information on your IoT devices so you can have real-time analytics, not just by your parties, but also by third parties. So I'm going to skip the slides, and apologies for the graphics again, but what we allow is our software will be deployed on devices and create a secure virtual machine on each of your individual devices so that you can cut out the middleman cloud infrastructure that you have to work with. This allows you to keep the data local, solving many data privacy problems, and allows analytics to safely travel to your devices. Here we go. Thank you very much. Allows you to send the analytics safely to the devices to work inside of the secure enclave, which is a virtual machine. This then allows the code to not interact or affect your IoT devices, and then can send back to your results. We'll go through this again with the graphics. But think about you are a fleet of cars, or you're working on a mobile network, or you have machinery. You have data that's local to that device. It's terabytes of IP-sensitive information, and it's difficult to bridge that gap between where your data is being generated and the analytics outside of your firewall. So we create a secure, encrypted copy of your data, put it into our secure virtual machine, and then send the untrained algorithm out across your network of IoT devices, train that algorithm, and either keep it local to work on those devices, or to return that trained algorithm back to the analytics team that you're working with, such as a hot new MIT startup. So we're ready to deploy this today. Our confidential computing software is working with businesses today. We've gone through this summer working on POCs. You take a look here at our analytics platform. We manage the data transit, we manage the algorithm and code transit, and the secure computation on your devices. So if privacy or security is a concern for your company, come talk to me afterwards, and you can find us online at secureailabs.com. Thank you.
Hi, I'm Jana Eggers, CEO of Neurologics. We're a proud member of the STEX 25, and we come out of the Brain and Cog Lab at MIT. We have a platform made for powering IoT applications. It wasn't built for that, but it fits great within it. Let me tell you some about that. Most people are going through, I'm not sure what happened on the graphics, but that's fine. So most people are going through this digital transformation, and that's really what we were working to solve is, as people got more digital data, how do they incorporate it and understand it and react to it, both for personalization on one side and decision support on the other. What happened is our customers started coming to us as they added more sensors and said, we don't know how to marry the sensors that I have with my inspection reports, right? Very different granularity on that data. You've got very fine-tuned on most of your sensor data, as you've seen before, but very coarse-grained on your inspection reports. And so that's something that our platform was built to do, is how do I bring different types of data together, marry them for the right timing, for the right types of information to provide decision support. So let me go a click deeper on that. So we do decision support for intelligence. We work with the US government. You can imagine the sensors that they have going on. We're looking at what events might spark something like an Arab Spring. We were able to provide them with 40% better event resolution. So they actually knew what the information that was coming in was married to that event that an analyst was looking at. We were also able to integrate that across systems for them, so all analysts were able to have it no matter what their mission was. We've also worked in the process engineering side. We were able to predict leaks 2 weeks earlier. Again, not just from sensor data, but from marrying sensor data to other reasons. And the reason why we were able to get acceptance is because we have transparent AI. We actually give the why reasons for why we're saying, look at this alert. We do that, like I said, we come out of Brain and Cog, so that purple box is what we call the connectome, which is how we marry data together. And that's our secret sauce. We're able to deliver better results, that explainability, and integrate within various systems. What we want from you all today is we want to know if you're pursuing a build strategy, we're great with that. We help you bring all of your sensors, all of your systems together so that you can make those decisions. We really work with people who are moving beyond pilots and into production. So a big focus of our proof of concepts is making sure that you actually go into production. And we look forward to talking with you later today. Thank you.
So what you just saw were 5 startups for our startup lightning talks. The first part is about the technology enablement. So you see all the way from the battery, the sensors, to using AI and machine learning to get you the best way to analyze that data and help you with decision support. The second part of these startup lightning talks will be talking about, we have another 5 startups coming up, and they are more about the applications for IoT and edge computing applied to various problem domains. So first up is Tactile.
Okay. Hello, everybody. My name is Harrison Braylauer. I'm the CEO of Tactile. Our MIT connection is that I studied here as an undergrad and a master's student. And I'm here today to talk about the hidden factory, and that's something that I hope John Carrier, who's moderating a panel later today, will talk at least a little bit about. What's going on in this picture? It is very difficult to figure out what all the things that are happening with the people, the materials, the machines in this picture. And for more labor-intensive environments, we currently do this with manual supervision. Typical factory has maybe 1 supervisor to every 15 operators. But it's slow and it's unreliable, right? It's subjective. We manage by eye. We're going to write things down. It can be political. Some people in the factories don't necessarily like each other, and if I'm writing things down about you, maybe I say things about you that I don't like. It's not real time, right? This line is moving at maybe a couple units per minute or something like that, but the supervisor cannot be everywhere all the time. So then it's missing high variance events, high risk events. Cost of downtime could be thousands of dollars per minute, depending on what you're making. And I think the most important thing is that it lacks context for why problems are occurring. We regularly talk to people who say, well, I've got lots of data about what's going on around here. Okay, but why are the problems happening? Just transactional data about units and things that you're making isn't enough. So our solution here is IoT sensor retrofits. You've heard a lot about that today, as well as the requisite analytics to go with it. We use machine vision to understand where, when, and what is going on with resources that are not instrumented in the factory. So like I said, labor, work in progress, anything that doesn't have data coming out of it automatically. We also have retrofit power monitors for legacy equipment that is typically used in these types of labor-intensive operations. core technology, like I said, machine vision. We do some signal processing over power monitor signals. Steve Lieb talked about that earlier. Together, we call this continuous process identification. What in real time is your factory doing all the time that you may not get from traditional data sources? You get that on a dashboard, of course. Labor analytics is really kind of the star of the show here. And what this technology ends up doing on the whole is automating that supervision task so that the supervisors can go back to doing what they do best, which is solving problems and not taking data. So one use case that we've hit on recently is distribution. Distribution centers are the kind of ultimate low volume, high mix, labor intensive operation. So we've been doing an accelerator program with a major East Coast grocery retailer this summer. And this is not their site, but it's representative of the types of scenes that we are analyzing for them. So it's not just, how many pallets, how many forklifts, things like that. What are the specific tasks that the people are doing here, and what is the task characteristics that introduce variance into the operation? Two guys disassembling a pallet, the pallets that come in are completely different, and if they're being held to the same standard, that standard should adjust for the type of work that we ask them to do. Really, they'd like to be able to enable personalized coaching, compensation, things like that tailor management to the workforce. So our ask here is that if you have labor-intensive production, old equipment, you do a lot of low-volume, high-mix, customization, we'd love to talk. It's not just about shop floor management. It's also about financial. Quoting and forecasting is a major consumer of this data. And like I mentioned, training, learning, and development. Come talk to me after the startup talks. Thank you.
Good morning. My name is Chris Aiden. I am the co-founder and CEO of Fringe AI. I graduated from the SDM program with a master's degree in management engineering in 2008. At Fringe AI, we provide turnkey inspection solutions to factories as a service. So this might be a typical organization inside a factory, in particular a meatpacking industry, where you've got from left to right the green hats, the blue hats, the orange hats, and white hats. Green hats, those are your business leaders, might be the factory manager, some of the generals on the floor. Blue hats and orange hats, those would be your technicians, your maintenance engineers, people that generally carry a tool belt, used to working on conveyors, things of this nature. And then you've got a whole army of the white hats. The white hats largely are unskilled laborers, and they're doing a lot of the manual production at the factory. So what's the problem? The problem is that all these white hats are very expensive. At about, if you imagine 1,200 white hats in a given factory, at $40,000 a head, that's an operating expense of $48 million a year. And a lot of those white hats are doing jobs that are really that people are not cut out to do. They're moving product from point A to point B. They're doing visual inspection. They're not actually adding value to the product, okay? So now our customers are the green hats, the blue hats, and the orange hats. These are the guys that, again, they care about the health of the business and making sure all the equipment and the volumes are running up to their standards. So what is our solution? So basically, we provide an edge processor that connects to sensors and actuators that is connected to our cloud services through the IoT infrastructure. That allows us to develop, deploy, and support the AI models, which really, it's not you don't do it once and walk away. You have to actually be able to tune these models over time, and that's what the IoT infrastructure allows us to do at a relatively low cost. We also stay connected to all of the assets in these inspections. So again, it's not just an AI play. We're actually talking to the actuators, the sensors, and the whole system to make sure everything's running at peak performance. So the benefit to the customer is that we can eliminate that OpEx. And if you figure that at least 30% of the factory is doing these non-value add tasks, that's $13 million a year in OpEx savings. And then you get all the benefits of higher quality and throughput, et cetera. Here's a typical application. This is our first deployment. This is at one of the largest meatpacking plants or companies in the world. What we're doing is we're classifying the pork loin as either cut side or rib side. We're controlling the actuator down here that's actually putting these loins onto two conveyors. What you don't see is presently there are two individuals at the end of those two conveyors whose only job it is to pick up these 40-pound loins, move them to the next stage of the processing. So that means by deploying one of our systems, you save the customer $400,000 over 5 years. All right, and that's just two of those positions. So the partnership ask for us is we're really focused on the industries, meat production, agriculture. Why? Because the need there is great. They haven't had the inspection technology to actually automate. Now they do. But it's not just the inspection. You have to be, or it's not just the modeling. You have to be able to do the whole inspection, which is where we're focused. As far as our priorities, we are looking for both teaching and learning customers. Learning customers, I say that because we've been in the industry. Not everybody is comfortable partnering with somebody to do inspection. So if you're willing to explore that, we're willing to do that with you. So that's what we mean by that. And then, of course, we're looking for both strategic and financial partners to help us build our business. Thank you.
Hello? Good morning, everybody, and thank you for the opportunity to present to you IoT Oxus Corporation. I am Anthony Kufal, the company's Chief Technology Officer. Oxus was formed when a team of veteran executives from various industries, researchers from facilities such as Los Alamos National Labs, and academics from MIT came together and decided that we could attend the needs of large-scale manufacturing operations in a better and more efficient way by pooling our talents together. And so we came to the observation that most manufacturing operations were trying to become more efficient, which is, typically referred to as Industry 2.0 in our conversations. And we recognize that that means that you have to combine your OT with your IT, take the data from that and put it into some kind of a mathematical model to analyze the data that you're capturing, and have domain expertise to be able to look at the results and the information that's being provided to you by that model and understand what it's telling you and understand what to do because of it. And because of the lack of end-to-end solutions that we found, we decided that we would attend these problems and we would help our clients achieve benefits such as asset efficiency and utilization, intelligent needs-based maintenance. So we're looking at what the machine is telling you it needs, not just that it's been a month and you need to change the oil. Failure prevention, we can actually capture enough sensor data to look at a manufacturing process and tell you whether it'll succeed or not, and I will show an example of that later. And manufacturing efficiency, amongst others. And of course, this is all to help our clients reach a better bottom line. The way that we approach this is we start with an exploratory analysis where we literally create a strategy of what data we need to capture, what is relevant, what is not relevant, how we want to capture it. We move to look at the data then and create some simple state classifiers to define what is nominal and off-nominal behavior. We then take those classifiers, run them through our proprietary machine learning algorithms, which we've developed our own to attack these problems. And what they do is they combine all the different classifiers to give us much better results. And finally, we implement it into a real-time device that can run in parallel with the manufacturing process and monitor what's going on as it runs. So looking at an example, which we recently completed for a global pharmaceutical company, they have a very large, complicated process that takes 7 days to run from start to finish for each production run. And because of the aging of the machine, the process was starting to have an increased number of failures. And so, of course, they were losing a 7-day production run every time something went wrong. We were able to start looking at the data they had, and just using the existing data that they had from their data loggers, we were able to narrow it down from 79 different sensor sources to 4 that we found that were relevant, because why capture data that you don't need? And we started our process of applying our human expertise and looking for the classifiers, combining all the classifiers with machine learning to become more accurate. And the result of it was that we can actually predict with almost 100% accuracy within the first 30 minutes of that 7-day run whether it will complete successfully or not, allowing our client to reset the process if they see that there might be a fault condition occurring down the road. Our ask is very simple. We're simply looking to grow, so anybody who has a large manufacturing operation, whether it be biotech, pharma, automotive, aerospace, defense, we've also worked with government doing structural health monitoring, some agriculture work. Please come talk to us and see what we can do for you. Thank you for your time.
Hello. My name is Elliot Gould. I'm the Director of Data Operations and Analytics with LineVision. I'm going to talk to you about our non-contact transmission line monitoring system. So the problem. On one hand, we have growing variable generation, often solar and wind power installed in remote areas, and we have this inflexible, aging transmission infrastructure trying to bring that to load centers. Just last year in the US, we saw $5 billion in congestion costs. A lot of that was renewables being curtailed. This isn't just a US problem. We're really trying to address a $6 trillion transmission asset market worldwide. So let's talk about the technology. So our V3 non-contact transmission line monitoring system, you can see a picture of it depicted on the right here, installed at the bottom of a transmission tower. In the boxes, we have an EMF sensor that's monitoring the power flow on the lines, as well as an optical sensor that is looking at the actual conductor position. So as the conductor heats up, it sags, and as the wind blows it, it moves left and right. So we can see that in real time. We're connected to our cloud infrastructure with typically LTE connectivity, but we can also do satellite connectivity. It's all self-powered here, so it's solar with a battery backup. We're currently working with primarily pilot projects with utilities worldwide. And we have 3 applications for utilities depicted on the bottom. Let's dig in a little bit more on one of them called dynamic line ratings. So we worked with SPP and AEP, which is in the southwest US, on a pilot project here. They identified a line that was highly congested, and we installed our technology on that line and compared our dynamic line rating to their static rating. So what happens, most utilities are currently operating with what's called a static rating. When they install that line, they look at the worst ambient conditions, the hottest day of the year, the most solar radiation, no wind, and they say, okay, what can I safely flow on that line? And they use that rating all year. What we're doing is by installing this technology, we're looking at those conditions in real time and telling them what they can safely flow power on that line with. And what that adds up to, in this 2-week period, we saw $18,000 in congestion savings just on this one line. That translates to a 3-month ROI. So that's a summary of what we're doing. Right now, we're looking for introductions to additional utilities for pilot projects, as well as anyone who may already have an integration with the utility. If our data, you think, could add some additional value to that integration, we're definitely interested in talking about partnerships. Thank you.
Okay, good morning everyone. I'm Sebastian. I'm the founder and CEO of Acoustic Wells. I recently finished my PhD here, and we won the MIT 100K startup competition at MIT last May. So, quick overview of the problem. There's a lot of producing oil and gas wells in the US, and most of them are smaller wells, typically less than 15 barrels a day. Those wells are old and they have a higher failure rate, and they also leak a lot of natural gas. And those are the wells we are targeting. There's 2 innovations. The first one is we are using sound diagnostic to detect what's happening far on the ground in real time. So it's very similar to a stethoscope. Any issue that affects the pump will change the sound at the surface of the wells. And this is what we record. The second innovation is an IoT system. We are placing very small, low-power units around the machine. Each can record a different variable, and they don't require any configuration or setup. We've managed to make them run on very low power. We can run things like TensorFlow right on the edge. And this also means that drastically reduces the amount of data that we actually have to transmit. And now that opens more choice for networks. We can use very low bandwidth networks that have much broader coverage. This also means that a non-trained user can install the system. You don't need to bring a qualified or certified electrician to wire things. The currently used labor force is able to go there and place those units, and there is no downtime for the actual producers. The data is then sent to the cloud. We have a second layer of analysis on top, and that is displayed for typically the owner of the oil fields. And we are talking about owners that have a couple hundred assets, and so that also reduce the amount of driving they need, the inspection need. and those can be in very remote locations, so that's a lot of man hours. So we're here, we're looking for contacts both in the oil and gas industry, but also in other heavy industries, people that could be interested where application of simple install are important. We have in mind typically industries where there are miles and miles of pipe, water industry, city gas infrastructures, for example. So don't hesitate to reach out. I'll be here after. Thank you.